Good day, everyone. And once again, we're back together. And today we'll be looking at question 5, which is based on functions. So if you haven't subscribed, please just make sure you're part of the family. And of course, you can always get in touch with us. Our website is mlungisinkosi.co.za. And right, I just want us to delve into this question. Let's look at it. Question 5, they give us f of x, which is 4 over x minus 3 plus 2, and g of x, which is x plus 2, right? Now they say to us, write down the equation of the asymptotes. Now, remember, so we're given two functions here. So if you haven't watched our videos on functions, please, this would be a good time for you to do that, even though they are written grade 12, but they are also relevant for grade 11. Right, so if you think about a hyperbola, in this case, we know this is in the form f of x, which is a over x minus p plus q. Now remember, this value here, right, tells us about what we call, in this case, the horizontal asymptote. In fact, sorry, the vertical asymptote, right? So this would be the vertical asymptote. So it means that your vertical asymptote would actually be x is equal to p. Note that it changes sign, right, when you place it as an equation, right? So meaning that your horizontal asymptote would be y is equal to q. So the p and the q value tell you about your asymptote in this case. Now, in this particular graph that we are given, we've got f of x, which is, okay, that's going to be 4 over x minus 3. So that's 4 over x minus 3 plus 2. So the values of our asymptote in this case, so it means that your first asymptote will be at x is equal to positive 3, right? Remember I said it changes sign, as well as another asymptote would be at y is equal to 2. Okay, right, so those are the two values of your asymptote, right? Now the next question, they say determine the x-intercept of f, right? So remember what happens at the x-intercept. So we're looking at 5.2, right? What happens at the x-intercept? We know that y is equal to 0, right? So where is this graph of f of x equal to 0? So it means that when we say f of x, 4 over x minus 3 plus 2, we know this graph would certainly be equal to 0. So all we simply do, going to say 4 over x minus 3, right? I'm going to take this to the other side, so that's equal to negative 2. So now, if we cross multiply, so remember that's negative 2 times, over 1 rather. So we're going to say, well, this is the same as saying negative 2 into x minus 3. So we cross multiplying there, right? Which is equal to 4 times 1, that will give us 4, right? So I'm going to divide both sides by negative 2 rather. Okay, so that cancels with that. So x minus 3 is equal to negative 2. So therefore, it means that x is equal to, if I take the 3 to the other side, it becomes positive. So it's positive 3 minus 2, that will give us 1. Okay, so it means that would be our x-intercept. So if you're looking at x-intercept, I'm putting it in coordinate form. So it would be, in this case, at 1 and 0. Okay, so remember we said that is where y is equal to 0. And then the next question, they say determine the y-intercept of f, right? So now, remember, so 4.3, y-intercept, this is where x is equal to 0. So we're going to substitute 0 everywhere we see x. So remember, we've got f of x is 4 over x minus 3 plus 2. So f of 0, so we're substituting 0 in the place of x. So that's 0 minus 3, right, plus 2. Okay, So we've got negative 4 over 3 plus 2. Okay, you can put that in the calculator if you want. Okay, so that's going to be negative 4 over 3, right, plus 2, rather plus 2. And so that gives us, I'm going to put it in fraction form, and that gives us 2 over 3. Right, so it means that our y-intercept, okay, should be at where x is equal to 0 and y is 2 over 3. Right, so that's our y-intercept, right? Okay, for the next question, they say sketch the graphs of f and g on the same system of axes. Show clearly all the intercepts with the axes and any asymptotes. Now what I'm going to do is, let's start with, remember the graph of g is x plus 2, right? So we'll come back to that. I just want to draw the graph of f first, right? So I'm not going to draw it to scale, ladies and gents. I just want us to get an idea of what we are doing there. So there we are. So we said, first of all, we're going to have asymptotes. Now, if you remember, we said our asymptotes are going to be at x is equal to 3, right? And y is equal to 2. So we know x is equal to 3. Let's put it somewhere there. Okay, so that would be our vertical asymptote, and y is equal to 2, so it means our graph is going to exist. Those are going to be our asymptotes, right? Now, we know by the way, the a value, we said when the a value is greater than 0, so this value here, right, is greater than 0, so it means that this would be a hyperbola that's in the first and the third quadrant, right? But if a is less than 0, then it would exist in the second and the fourth quadrant, right? So in this case, what we would have is, okay, we know it cuts the x-axis. Remember we said our x-intercept is at 1 and 0. So where x is equal to 1 and y is 0. Okay, so there's our x-intercept. And our y-intercept, it's at 0 and 2 over 3. So let's just say 0 and 2 over 3 is somewhere there, right? As I said to you, I'm not going to necessarily draw it to scale, right? This is the value, okay? Y is equal to 2. This is the value, x is equal to 3, right? So it means that our graph would cut through, okay, so this one here, we said this is 1. So it means our graph is going to cut through those two values, okay? So it would continue in that direction, okay? And the other part of the graph would be in our first quadrant. So this is what our graph would look like. Okay, sorry for having it kind of intruding into the last example there. So this is what our graph would look like, right? And then now let's look at the graph of g, right? So we know that g of x is equal to x plus 2, right? So what would be the x-intercept? So this is where y is equal to 0. So y-intercept, this is where x is equal to 0, right? So we know if we substitute g of 0 there, it will simply give us 0 plus 2, which is 2. So we know this graph would cut at y is equal to 2, right? So that would be at the point 0 and 2. And our x-intercept would be at where y is equal to 0. So it means that we're going to take x plus 2, make it equal to 0. So that would be at x is equal to negative 2. Of course, when you've done this, long enough, you kind of figure it out quickly, right? So in this case, what we've got there is that it will cut also at where x is equal to -2 and 0. So let's kind of draw our graph there. So let's say that's going to be -2 and 0. Okay, our graph is going to cut there. And then it's also going to cut at 0 and 2, which is that point over there. All right, so I'm going to try and draw it in a... okay, so there's our graph. All right, okay, I couldn't get it right. So maybe let's use a ruler. Okay. All right. So, yeah, let me try and connect those 2 points there. Right. So that's what our graph would look like. It has a positive gradient. Okay. It cuts through -2 and 2. Okay. So that is what it would look like. Sorry about it kind of protruding there into the last example, but that's what our graphs would look like, right? So now we are looking at the next question. They say to us, calculate the coordinates of the points of intersection of F and G, right? So they want us to calculate those. So we want to know where are they going to intersect. Now, in this case, what we're simply going to do is we're simply saying, so where f of x is equal to g of x, right? But we know that f of x is 4 over x minus 3 plus 2. Where is it equal to the graph of x plus 2? Okay, right. So remember, you just take the equations as they are, you equate them to each other, right? So, right, already I can see something that, well, you've got the same number on either side, so they're going to cancel there, right? So you've got 4 over x minus 3 equal to x, okay? Right, so all I'm going to do is cross multiply, right? So cross multiply like that. So what do I have? X, let me just go back to that color. So x into x minus 3 is equal to 4 times 1, which will give us 4. So I end up with x squared minus 3x, okay? If I bring the 4 to this side, it becomes negative, so that's minus 4, which is equal to 0. So that's going to be, if we factorize, okay, that's 4 and 1, factors of 4, such that when I subtract them, give me 3. That's 4 and 1, okay? So that would be negative, that would be positive. So x is equal to 4 or x is equal to -1. So they are going, or rather the graphs are going to intersect where x is 4 and, or rather, where x is equal to -1. Now the corresponding y values, you can take either one of the two graphs. I'm going to take the straight line, so y is equal to x plus 2. So in this case, I'm going to substitute both the values there. So that's going to be 4 plus 2, so which means a first point of intersection will be at where x is equal to 4 and y is equal to 6, right? And another point is where x, now y is equal to -1 plus 2. So the other point would be at 1, -1 and 1, right? So that would be -1 and 1. Now, if you go back to the graphs, let's see if that kind of makes sense, right? So there's the point of intersection there. And it's telling us that that point there would be -1 and 1. And it makes sense because x is negative there and y is positive. And the other one is that point over there. And it's telling us that point is where x is 4 and y is 6. Okay, so that kind of makes sense from that perspective. Okay, right. So we've got our 2 points of intersection over there. Right, now the next question. Okay, moving right along. Right, they say if x is less than 3, right? So it means we are looking at any point that is less than 3. They say determine the values of x for which, now notice this is our f of x, right? So for which f of x is less than g of x, right? So what does that mean? Where would f of x, the hyperbola, be below the straight line graph for any values where x is less than 3, right? So let's go back to our graph. Okay, so which means we are focusing from this point going all the way that way, because remember, going that way, this is where x is greater than 3, right? Now notice, where is the hyperbola, right? Remember they said, where is f of x less than g of x? Where is the hyperbola less than, or in this case below the straight line? So look at this. It's between that point where they intersect all the way up until this point here, right? The straight line is actually above the hyperbola, all right? So, and from this point here, the hyperbola starts being above the straight line. So we were looking for the point where the hyperbola is below the straight line graph, right? Remember, they said where 4 over x minus 3 plus 2 is less than x plus 2, right? So we want this one to be below. So this is for all x is an element. Now remember, at this point, x is -1 all the way up until x is equal to, x is 3, and both are excluded in this case because we want less than and not equal to. So to answer that question, I think that's 4.5 if I remember, right? So we're going to say x is an element of -1 all the way up until 3, and both are excluded, right? Or you can say x is less than 3 and greater than -1. So you can actually express it there, whether in inequality form or in this case in the other format. Okay, right, so that's what our graph would look like, right? Okay, the last question, they say the line y is equal to x minus 1 cuts f at 1 and 0 and q. Write down the coordinates of q. So now we are introducing another graph, which is y is equals to x minus 1, right? So we want the points where that graph intersects with f, right? Okay, so we want the other point. So that's 4.6. So we're going to say, right, what is our graph? So this is where f of x is equal to x minus 1, right? So that's going to be 4 over x minus 3 plus 2 is equal to x minus 1. Let's try and be as quick as possible about this one. All right, so we're going to say this is 4 over x minus 3, going to take this to the other side, is equal to x. Now if I take this to the other side, it becomes negative, so that's x minus 1 minus 2, which is x minus 3, right? So if we cross multiply, we're going to have x minus 3, right, squared, so x minus 3 times x minus 3, right, which is equal to 4. Right, I'm going to just take the square root on both sides, so remember that's plus minus, so this is going to be x minus 3 is equal to plus minus the square root of 4 is 2, okay? So x would be equal to x minus 3, sorry about that, so x minus 3 would be equal to -2, or x minus 3 would be equal to positive 2. Now you'll see that x is equal to, right? This is 1. Do you remember they gave us this point? So we don't need to actually look further here. But we wanted the other point. They wanted the point Q. So it's x is equal to 5, right? So in this case, we're going to look for the y value of x is equal to 5. So you take either one of the two equations. I'm going to take y is equal to x minus 1 because that's one of the graphs. So in this case, that's going to be 5 minus 1, and that would be equal to 4. So which means the point Q is 5 and 4. That is how the cookie crumbles, right? If you want this question paper, it's from the 2018 grade 11 exam, right? Sorry, that was 5.7. I said it's 5.6. Actually, I kept on saying 4 rather instead of 5. Sorry about that, but you get the point, right? So that was 5.7. Okay. So that's 5.7, meaning this one, that was 5.6. Okay, and of course you'll continue going all the way up. Right, so ladies and gents, that is how this question goes. I hope that you were able to understand it, right? We will continue looking at functions as we go along. Thank you, and I'll see you guys next time. Please don't forget to subscribe and like, and also share to as many people as possible. Otherwise, from me for now, sharp sharp.